So we've looked at the circuit diagram and we can see that this capacitor here, if I try to explain how it kind of works, it's sort of there are types of microphone called electric microphones which are used in modern day phones, and they need a DC voltage across the terminals to activate the package inside, but then the output of the microphone is on the same terminals, but we need to put a capacitor. It basically filters out any interference from the power and lets the sound flow through. That's how the capacitors work, and these are very similar to what we got here. These are letting the AC through and blocking the DC. It's very similar again. That's the dial. That's dialing just like a normal dial, and this particular works of pulses. So if you so many pulses, say you did click 4, pulse, 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 pulse. On a normal phone line today, we've got tone dialing. So when you press the actual thing, it goes beep, 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 beep. It's just exactly the same as this. So 4 might be beep, and 5 and 6 might be beep. So it's the difference between the tones. Instead of it being pulse, click, 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 it's working off one tone. And there's a generator inside modern phones that generates that tone, and that is basically sent down the line, if you like, and a bit like with a microphone, and you can actually hear it on the microphone as you're from a headset as you're pressing the tones. So it just does the same thing, except this is pulse tone dialing, and the modern one is tone dialing, DTMF. I forget what it stands for now, dual tone, something, I know, I can't remember what it is. But it's quite clever how it works. Okay, right, so moving on to this other phone. I've just been looking how the dialer works, and I don't know if you can see this. I might better just do it, but watch how many times that switch. So if you cut it all the way to 1, 2, that must be 2, that clicks that 2 times. If I take it all the way across right to the end, which would be number 8, I think it would be. Is that number 8? Number 9, there we are. That's all at the end. Now watch how many times, not 9, that was 8, this is not, so hang on. That's 9, that's it. So watch this. Ready? That's how that number is dialed. So basically what you've got there is like, there's 2 switches here. Okay, with my screwdriver. Got these 2 switches here are what's showing together every time we turn that dial. As you can see, so that's 2, and that's 3, and that's there. There is a mechanism in there as well. You can see it just spinning around inside. Yeah, it's like clockwork inside actually. That gives it something so that it slowly goes back, not too fast, otherwise it won't work. So that's, I can't remember what they call it, some sort of friction device that, yeah, I see, just like a clock has the thing that makes the thing ring, causes the bell to chime. It's a very similar thing. I think it's called it's like a governor, I think it is, or something. I don't know what it is, I can't remember what it's called. Anyway, that's what that is there. This is sort of spinning round. That gives enough time for this here to go click, 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 but quite fast. As fast as analog will actually go in that respect, because it's very difficult. This is why we use tone dialing, which I mentioned before. That's the dialing mechanism, and that's how it works. And of course, these are your wires coming out of that switch. There's that switch there. And there's also a thing that tells it when you've dialed that particular number, when you've stopped, sort of thing. There's another, I think there's another switch in here somewhere. Yep, there. I'm not too sure what it actually does. So look. Oh, that one does the same thing. So, so it's, yeah, you can see it inside. There's some 2 switches doing it there. Look, see it? That must be, so we've got inside there, we must have these 2 wires, there must be 4, and then there's the 5th wire. So, right, I see how that works. Contacts. That's so that it can dial up, it can, what they call, pulse so many times per second to dial that number. That must be how that works. I don't know much about these things myself, because dialing mechanisms is not something I've really worked on. But yes, you can see these switches here. So that's what they do, that's the dialing circuit. And of course, however many pulses is detected by the exchange, or by the second unit, if you like, you can dial one of these up, you know. So let's say connect this to the telephone line, the normal line, and then you can, as long as you convert the pulses into tones, but the pulses are generated here, and then this tone converts them to tones. It does a very similar job, except it's a lot quicker, because it's beep 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 beep. It's really, really quick, and at the exchange they detect which tone means means each number. So in each number has its own frequency, just as the pulse frequency from here is the same. So that you can see how it works. This is a bit slow, but a normal pulse dial, normal DTMF type, they are a lot quicker. Instantly get through. That's as soon as you've pressed the last button and you pause, it's straight through. Whereas this is going 7, 6, 3, you know, and so on, until you've got the number that you've dialed the number. Then it detects that pause, and then it rings a number. But unlike these the tone ones, as soon as you've let go, it's straight through. Whereas this is doing it one number at a time until it detects that pause, and then it says, right, that's the number you want, and then it connects you to that particular exchange number. And that's how this phone dialing mechanism works. Again, quite simple. So if I'm just going to quickly demonstrate the buzzer, just switch this one on. So I've got another one here, as you can see, which I'm using. So I've got 3, one prepared earlier. See, good old Blue Peter style. So I've attached an LED. So you see that LED? Just about to see it. I've connected that LED. Now, if I just disconnect this, just hang on a minute. Right, we're back. So all I've done, let's get the light on here so you can see it. So all I've done is to put the receiver back on the handset, a bit like this basically, like that. Yep. So that's what I've done on this one here. And then all we're doing, we are pressing this button here, which is the LB ring. So you press the LB ring, that sends a voltage across here and makes this buzzer work. So I'll give you a demonstration. A demonstration, as what's his name used to say. Ready? See, can you hear that? Now you will notice that the LED is not lit. That's because it's using this. Watch. Show you quick. Wherever it is. That's the thing that's making the noise. vibrating. That's it. So that's like a coil. That's how that does. But if I disconnect that like this, but I'm gonna have to do it on here. So now I've disconnected that. Yep, just like you saw me doing that. Now if we click it again, you'll see that the LED lights and the buzzer doesn't work. And that's just because the way I've made this work. Basically, I've wired that LED into there, and that was what I wanted to do with these things, was to wire an LED across, so that if the handset was off, at least you'd be able to tell that somebody's trying to get in touch with you. Otherwise, you won't receive anything. It would just be sort of dead, and the person will be ringing from here, and because the handset's off, you wouldn't even know that they're trying to get in touch with you. So I've added that, but there is a complication there, because this is 4.3 volts, as I've said before, in here. And on a Monday voltage, there would be 48 volts across there. So I'm going to use a GPO relay that as soon as you plug it into a normal telephone line, it detects that it's a 48 volts, and it automatically switches it between a modern day tone dialing circuit and this LED to switch that off, and it switches in another LED which has got some resistance in it to work at 50 volts, and the opposite, the DTMF thing, to make it work as well. So that's what I'm planning to do with this. So there's going to be a few indicators on it and stuff and what have you. So when I've done it, I'll show you the finished product. But this is my lockdown project. That's I'm almost finished anyway. Okay.